there's the starting bell. All right, you guys. Let's get started on the exam review. We'll probably work for a good 20, 25 minutes on this. So again, these first problems, this is about our parallel lines and our transversal. If you remember what we talked about, if we classify as corresponding alternate interior, alternate exterior, then we know our angles are probably going to be, not probably, they're going to be congruent. If we end up with same side interior, same side exterior, then they're going to total up to 180 degrees. Difficult part about this is none of our classifications. All right. But this 11x minus 12 is the same thing as its vertical angle. And now I have same side exterior angles, which means they have to add up to 180 degrees. So the equation I should be making would be the 11x minus 12 plus 5x minus 48 equals 180. Mr. Spake, you're going to keep an eye on me to make sure I don't make any mistakes, right? Fantastic. Because this is recorded, and I don't want to be recorded as a doofus. I'd like everybody just to, I'd like that to be a rumor, So if we combine like terms, we have 16 x's here minus 60. If we add 60 to both sides, and then we should probably figure out what's 240 divided by 16. We're going to divide 16 on both sides. They want us to find the value of x. So x for this problem is 15. And if they also asked us to find the measure of angle 1. I know angle 1 is corresponding to this angle down here. So if I find this one, then I have them both. Just got to take the value of x, plug it in. Instead of 5 times x, I'll do 5 times 15. 5 times 15 is 75 minus 48. Looks like I got angle 1 equal 27 degrees. I don't hear Mr. Spake yelling at me yet, so I'm hoping that one went well. One down, 87 to go. I don't know how many problems there are, but there are a lot. That's why you want to start this early. All right, let's move to a different color. Same idea. JB, what's the classification of these two angles here? Alternate exterior. What you nailed it quickly to. That means they got to be equal. 9x minus 3. 6x plus 33. Kiddos, you doing this with us? Kiddos, which side of the equation has the most x's? Which side of this equation has the most x's? What's more, 9 or 6? Actually, 9 is more than 6. 9 is a bigger number. So I want to move all the x's over here. So I want to get rid of all the x's on the right. Well, that leaves me with 3 x's minus 3 and 33 on the other side. Start moving these numbers to the other side since I got all the x's on the left. Add 3 to both sides. And divide both sides by 3. We got x. Now, I can't really, x is angle 1 isn't the same as this one up here. But I do know that these two angles form a linear pair. So if I find this one, I can subtract it from 180 and find the other one. 6 times 12 is 72 plus 33, I think gives me 105 degrees. That means angle 1 has to be the remainder of the 180. So 180 minus 105 leaves me with 75 degrees. Fantastic. Next, new color. This is our segment addition postulate. If AB is x plus 16, BC is 5x plus 10, and AC is 56. This plus this has to equal the whole thing. So x plus 16 plus 5x plus 10 has to equal 56. Combine like terms. And begin solving for x. Subtract 26 on both sides. That leaves me with 6x equals 30. Divide both sides by 6. X is 5. They didn't actually ask for x. Find the lengths of A, B, and BC. It means we got to take that value of x, plug it back in. If x is 5. 5 plus 16 is 21. AB has to equal 21. If I plug 5 in here, 5 times 5 is 25. That leaves me with BC being 35. We're flying. Now, I will tell you, problem 4 is straight off of the exam. Problem 4, big deal. Because we've had a picture up until now, and we don't have a picture. If you don't draw a picture, you're going to be out of luck on problem 4. We need to be able to draw this. Angle LMN. LMN. And we need ray, MO. Bisect means cut in half. Now let's put all the values in there. LMO. LMO is this angle. That's 13x minus 24. NMO. NMO, that's this angle since it was cut in half. I know they're the same. That's x plus 84. They want us to solve for x and find this angle. Well, the equation, they should be equal. Okay, which side of the equation has the most x's? I've got 13 x's, and then I have x. Which one has the most? Which one's more, 13 or 1? 13's more. So we want to get rid of this x on both sides. That'll take away all the x's on the right. Leaves me with 12 x's. Minus 24 equals 84. And 24 to both sides. I think I'm going to intentionally make a mistake just to see if Mr. Spade catches any of my mistakes. I'm going to throw in one of these days. We'll see. Now we're at 12x equals 108. Divide both sides by 12. I think we get 9. And if we got to find angle LMN, that's the whole dang thing. Well, it's easy to plug 9 into here. 84 plus 9 means this is 93 degrees. The good news, I know they're the same, so this is also 93 degrees. If I want the whole thing, I'd want to add them up. This is not the best problem because we actually get an angle bigger than 180 degrees, but my math is sound. I haven't heard Mr. Spake yell at me yet. 186 degrees, but my math is good, so we got to stick with it. I told you this is straight off of the exam. That means we took the exam problem. We changed the numbers, and we didn't check well enough to see if everything was going to work out great. We cut some corners, and we paid for them as math teachers.
I think that's an important question to recognize. Why can't you bisect an angle greater than 180?
Does anybody think they have an answer to Mr. Spake, who sounds like he's going to be a phenomenal teacher in the future? Why can't we bisect? Nick, talk to us. I don't want to see no typing. Why can't we bisect an angle that's bigger than 180 degrees?
Okay, I think we can't bisect an angle that's larger than 180 degrees because 180 is a straight line, right? So if it's like that much of an obtuse angle, there's no way that, like, I can't visualize a way there can be, like, a way for it to, like, go from the center, and to, like, bisect in the middle.
Nick, do you see this angle?
Yes.
All right. And I love that you said 180 degrees. So first off, what do you think this angle is about equal to right here?
It looks about 90 or a little bit less.
About 90. You said if we get to 180 degrees, we're at a straight line, correct?
Yes.
And let's say if I go to 100, and if I go bigger than 180 degrees, what's happened now?
It's like upside down from before.
Yeah, we're not going to call this 100. Generally, we're not going to refer this as 190 degrees. All right, we're not going to look at this.
We would flip it over.
Yeah, we would be focused on this angle here, wouldn't we?
Yes.
Yeah, once we go bigger than 180, we're looking at the bottom side of this angle now. Nick, you're absolutely right. If we're socially acceptable, I would hug you, but don't worry, you're safe behind a computer. Fantastic. Let's keep going. Problem 5. This one could be intimidating. I'm trying to bully you a little by putting some words in here. All right, problem 5 says, a stage is set according to the following specifications. A chair is placed at point A, a table at B, and the lamp at C. If the distance from A to B is 8 feet, and the distance from A to C is 7 feet, what is the distance from the table to the lamp? Now, this is not the best problem, but I don't know if you guys can see, but there's a small square here. Does anybody know what that little square means?
90 degrees.
Yeah. Which means if I have a right triangle and I know 2 of the sides, is there a way, Deshaun, to track down the third one?
Yes.
How?
I know there's a way, but I don't remember how, being honest with you.
So one of the skills, Deshaun, that we've worked on this semester that you're going to need all the way to the very last day in this course, you've got to be ready to apply the Pythagorean theorem. Do you remember what that was, Deshaun? Deshaun, do you remember what that was?
I was thinking, but no. Just write it out, and then I'll try my best to remember.
Okay. Anybody want to help Deshaun out? Because I don't want to write it out.
I got it.
What do you got, Evan?
The Pythagorean theorem is a squared plus b squared equals c squared. It's the sides of a triangle.
So the C there has to be the longest side, called the hypotenuse. So the C, the hypotenuse, is here, which means we just have to plug in the other two numbers to the other two letters. So we need to do 7 squared plus 8 squared equals C squared. Evan, what do we do next once we plug those values in?
You do 7 squared or 7 squared, which 7 squared is 7 times 7. 7 times 7 is 49. Then 8 squared is 8 times 8, 4, which is saying that, so 49 plus 64 is 113.
That doesn't look like 113, though, Evan.
Yes, it's because you have to do the opposite operation. You have to square 113.
Careful, I already have squaring. What's the opposite?
Well, dude, the square root.
Yeah, I need to.
That's what I meant. I meant square root.
I'm with you. We got to square root both sides.
Opposite operation.
Yeah. Lucas, what are you saying? Yeah. Thank you, Lucas. Yeah. So if you want to plug that into a calculator, does everybody know how to do a square root on a calculator?
Second x squared.
Yeah, x squared is right here. And you'll see in blue right above it is a little square root symbol. So second, we'll bring up a square root and I can put in whatever number I want. 113, which means my answer is about 10.6. Now, number 6. I love number 6. Come on, everybody in the room needs to be trying this one. Consider the pattern of the numbers shown below. I don't know if you guys know, but this is actually a very famous pattern.
Oh, yeah.
Mr. Spake, do you know the name of this pattern? I bet you do.
Well, it looks like Pascal's triangle, but I don't know if the numbers are right.
Oh, you know what? Well, hold on. 1, 3, 1. No, you're right. It's not Pascal's triangle.
I think I know it.
Pascal's triangle would be the beginning's a bunch of ones, right?
Mm-hmm.
This would be Pascal's triangle. Look at me getting all. I was thinking we were looking at Pascal's, but it's a little different.
Also, just a quick question on number 5. How important is it that we need to put units on that? Because 10.6 what, right?
Yeah.
Is it just 10.6, or do we need to be careful and include?
Yeah. Does everybody understand what Mr. Spake is saying? If we're talking about feet, let's make sure we understand. Are we talking? Because there's a lot of difference between a foot and a centimeter and a mile. Even or whether we're talking about a whole different topic of degrees as well, you know?
I think I know what it is.
Evan's already helped us out, though. Lucas, do you know what the next line in this pattern would be?
Oh, baby.
What do you think?
The next line of would probably be 1, 3, 5, 7, 9, 7, 5, 3, 1.
So what was the change between this line and the one before?
You just the middle. You replace this. You just basically add +2, and once you reach the next number down the line, you just repeat it backwards.
Yeah, that middle number, middle number, the odd number in the middle is just increasing each time. Good job. Page 1, we did it. I think we'll go through the second page here, and I'll probably let you guys go work. Need a little bit of space here, but I'll give you a little time to go work more on this review. But 2 pages down, I think this is a little intimidating because this is pretty much all one problem here. So we have all of these things that you need to be very aware of. Here's our choices. These choices need to help us describe these items down here. So if we have this, we have a B and A, a line with an arrow here. Does anybody have any idea what that describes out of that list? This is scary. We should have number 7 down pretty fast.
If only I could help on this one. I wish I could.
Yeah, Evan can't help out. Lucas has already helped out. London, you're trying to exempt my final. Let's be impressive, London.
What was that?
Hey, how's it going? Did I wake you up? Do you have any idea which of these choices best describes number 7? It's 2 letters with a line and 1 arrow above them. What do we call that? Do you see all the choices that you have here?
I don't remember all of the definitions for them.
Okay. Yeah, you may want to try and push for that exemption then, because this might be a little tough. Anybody want to help London out?
Can I help him out?
Nah. JB, what do we call it, JB? A line with 1 arrow? Thank you, JB. It's called array. I think number 4 is a bit more difficult. If we look up here, they're talking about angle 11 and the combination of 13 and 14. Anybody have an option that we can put there? Because I could technically see 2 different answers here at least. Carlo, are you working with us or are you just taking a nap, Carlo? Well, that answers that question. Guys, if we see this movement here that goes from this line all the way, we have this situation here. Well, you're not helping us out, Carlo. I would accept one of 2 different responses. You could say, we should at least say that this relationship here is a half circle, which should mean that we're going to have a total of 180 degrees. So at the very least, we could say that these angles are going to be supplementary. Some people might say that they're trying to compare angle 11 to this situation, which would also be a linear pair. I would accept either of those responses. If you look at number 9, they're talking about 12 and 13. So 12 and 13, let's go a different color here. The combination of those angles compared to this angle. This is difficult to see, you guys. But again, if we have parallel lines and a transversal, parallel lines and a transversal, they're asking us to compare this angle to this angle. Alternate interior. What do you guys think about points A, B, and C? Lauren, can you help us out on that one? Anything you notice about points A, B, and C?
They are like, oh, no, I don't know.
What? What were you going to say? I bet you had a brilliant idea. Anything you notice about points A, B, and C?
Oh, they're on the same line.
Yeah, which one of these words means that they're all on the same line?
I don't know.
Co-linear.
Oh.
Linear means on a line. Co means together.
Yeah.
Glad we're going over this. Number 11, angle 3 and angle 7. We got angle 3 here. We got angle 7 here. Anybody got that one? Come on, Pedro, you got to know that one. Where are you at, Pedro? What thing? What do you mean, what thing? If you're following along with us, come on, man. We're looking at problem 11. We're trying to compare angle 3, which is right here. We're comparing it to angle 7. It's got to be one of these terms here. What do you think, Pedro? Pedro, is your mic working? I'd rather talk to you. Guess not. No, they're not collinear. Stephen, you got to help us out, Stephen. Can't wait for this virtual education stuff to be gone. Stephen, where'd you go? Stephen took a break. I would agree they're on the same side, but the interior would be here. 7 is not on the interior, Stephen. What do we call angles that are on the same side? One of them's inside, the other one's outside. They're kind of in the same position. Angle 7 is the bottom left angle here. Angle 3 is the bottom left angle here. One might even say they're in matching positions. They are right angles. Is that one of our choices? Technically, that's not an awful idea. Technically, they are right angles, but they're also corresponding. They're in the same position, Stephen. So I'll give you a part idea there. This is why you got to go through this review, Stephen. You got to know it. All right, let's go look at 15 and 18. Come on, somebody's got to know this one. What do we call angles 15 and 18? We got to be able to knock that one out of the park. Luca, you got that one?
No.
Sweet. I think in order to keep us on pace, we're going to have to go a little bit faster here. I really hope you guys do some studying before this exam. Thank you, Pedro. It is vertical. $19 and $20. 19 and 20. There's a true linear pair. 16 and 21. 16, 21. They're both on the interior, but they're on alternate sides. Angle 3 and 5. 3, 5. Same side interior. And then line AB, line FG. FG, AB. If they intersect to form right angles, perpendicular lines. That's 2 pages down. You guys, you got plenty. I think there's 8 pages to this review. If you get it done, in my opinion, you're going to be ready for the exam. You'll have earned the 10 points that I will add to your exam grade. And you have, does everybody know when the exam is? Jameson, when is the exam for this course, for this class? He's right here in the room and he won't even talk to me. It is. It's the very first exam on Monday. So you got to get this done, you guys. All right. It is 11:22. I got to let you go at 25. You're out 3 minutes early. Please take care of continuing your work on this review and your preparation for success.